You guys do your
What? Alright, so today we're going to do 4-1-4-2, the 2x2 systems of equations. So our objectives that we're going to be working on, we're going to solve systems of equations by, I bet you guys know this by now, solve systems of equations by what three things? Elimination, substitution, to the G, graphing. Boom. And then we're also going to classify the systems of equations. Yeah, get your notes printed out. I forgot. I don't know. Okay, we'll do it next time. They have to go do it on their own. I don't have a plan. Yeah, I don't have one either. Library? I went there, but it's writing out like 25 pages. If you want to like front back over there, so you can figure out like. Okay, let's do that after notes then. Okay, I'll show you how to do that. Okay, so if I gave you something like this, right? One equation. One unknown, just the x's, even if I have an x over here. One equation, one unknown, right? Can you solve for it? Yes. What if I gave you this? Can you find the numerical value for x now? No. But if I then threw in, can you now? Two equations, two unknowns. Yes. So if you had three equations, right? Three unknowns, could you solve? You had four unknowns, four equations, right? Okay. Yes. So for however many like variables you have, that's how many equations you're going to need to get your numerical values. Okay? So let's see. A system of equations is a collection of two or more equations. Today we're going to be dealing with the two. So in our 2x2 system, we have two equations, two unknowns, or two different variables. So you have x and y, or you may like have a and b, but you have two different variables when you want your two equations. And if we're doing linear systems, then we're going to have lines. Okay? So right now we're just going to be dealing with lines, two unknowns. Two equations. So today should not be too rough. We'll work our way up a little bit. So you guys have been doing this for a while. So you guys are going to be pros, right?
No.
No, not at all. Okay, so a solution to the system, and even think about if you're going and graphing, the solution is a what? Point. Okay, or let's make it a fancier word and say ordered pair. But yeah, a point. Okay. Or we could have pairs, right? If they intersect in more than one spot, and they're going to satisfy all the equations in the system. So again, graphically, I'm going to put it right here. We have two things, and we're saying AB is that ordered pair, right? Graphically, it's where the two lines do what? Intersect. You might want to shorthand those notes if you didn't have them printed out and ready for today. Yeah, we can have that one. He's named after his great grandfather. All right. So why do we want to find where things intersect? So think about this. Let's say that you were looking at your cell phone plan. How many of you guys have a cell phone? Okay, you're going to go off to college. You're going to go off to the real world. You want to spend a lot of money. No. So you're kind of going to think about how many minutes you're talking, right, on your phone, or texting. How much are we really talking? We're just playing texting, talking, all that stuff, versus the cost. So, like, for instance, let's say that this was at, like, I don't know, let's say you only do 60 minutes in a month. That's not very much, but you're not much of a talker. Then which one would be the better value? Dial and go or connect now wireless? Well, look at the cost. Do you want a high cost or a low cost? You would want connect now wireless if you only did the 60 minutes. Okay, well, let's say that you talk anywhere between 60 and 120 minutes. Which one would you want?
Connect now.
Well, connect now is now more expensive. It's a buy, right? It's got a higher cost.
I talked a lot.
So you're going to then want dial and go.
It looks like they cross each other.
Well, they are crossing each other.
So wouldn't you want connect now since it's going to be cheaper the whole way?
It's only, okay, so from here to here, do you see how connect now is above?
No, I don't.
Okay.
Oh, in between. Okay.
Yeah,
Okay, I get it. I'm sorry. I thought we were talking because I thought
no, the actual red line.
Dial and go is the red, connect now is the green.
Because I thought we were just talking about how overall just it would just be cheaper to get
All right.
Okay.
Yeah,
Okay.
I get it now. Those
Those are just me making up some values. Okay, so from here to here, right, if you talk between 60 and 120 minutes, where are you going to go? Connect now or dial and go?
No, dial and go.
Okay, dial and go because the cost is less. But then, let's say that you talk over 120 minutes, where are you going to want?
Connect now, but it's not like you're gonna switch over dial and go just because you talk.
Wait, hang on. I still don't understand this.
Oh my God. So when we find where they can intersect, right, we can see where they're going to switch from one being higher and one being lower, right? Yes.
I like the green.
So if I'm going to try to get a cheaper price going on, right, and if I only have like the 60 minutes that I talked or less, then this is cheaper down here with the connect now. If I talk between 60 and 120, then this is now less expensive, which is the dial and go. If I talk 120 or more, then this is less expensive. So finding where they intersect can show me which can be a better price, right? Okay. All right. So let's see how we can classify these. Woo, that was supposed to be the fun part. Okay. Okay.
I feel like we'd be really fast.
So if they connect at a single point, if two lines connect, we kind of had that over there from our graphic at the intersection, right? If two lines connect at a single point, we call these systems of equations. Anybody remember? I'll tell you the three that you can pick from so you can see if you remember. Independent, dependent, and inconsistent. I think you remember any of those. If they only connect once. Independent. We're going to classify them in a little bit. Okay. What about if they are infinitely many points? So like if I had 2x plus divided by 2 on both sides here. Would I have that? Well, let's think the other way. What if I multiply both sides by 2? Same line? Okay. All right, what would be another line that's exactly the same as this? Thinking about that now. What about 3x, then what? Plus 3y, what would that equal? 6. Are all these the same lines?
I don't know.
Yes, if you solve for y, you'd have exactly the same thing. But do you see how you're just multiplying or dividing by a constant? Are you sure?
No.
If I took this guy and multiplied by 3, would I be here?
Yeah.
Same line.
Okay.
Okay? If I took this guy and divided by 3 on both sides, would I be back to there? Same line. Okay. So when we have the exact same line, instead of being independent, okay, it's where we have infinitely many. So when you go to graph, it's going to be the exact same line. So they're going to touch up everywhere. What's this one going to be called? Dependent. Okay?
Oh, hold on.
And if they never, ever, ever touch, what kind of lines will never, ever, ever touch? Parallel lines.
You go.
Then what are we going to call those? Inconsistent. So for instance, what would be a parallel line? What would be another one that I could pick here?
Y equals 3x plus 2.
Good. What if I had this? What would be a same line here?
Y equals 6x plus 2.
So you multiply this by 2.
Yeah.
You multiply this by 2. So what do you got to do here?
Put it 2.
All right. Are those the same lines now?
Yes.
Feeling good?
Yeah.
Kind of get it? Okay. So we're going to solve these by the graphing, the substitution, the elimination, and we'll go ahead and classify as well, even though I don't think it has that. So we're going to do this first one. And if it wants me to solve by graphing, what do I first need to find? If I want to solve by graphing, I need to first find...
Slow.
Why? What form? What form? How about that? Slope-intercept form. So let's get those slope-intercept form.
I know it's slow somewhere.
Are they the same lines?
Probably.
No? Look right here, right?
Oh, negative. Oh, I didn't even know. Okay.
So get it? Slope-intercept.
This is probably one of the stuff I think I don't remember.
Oh, yeah?
Yeah. Off your game. It's not the same. No, I wrote a 2 and such a 30.
Okay, see if you got those. Don't just write what I wrote. Check and see. And if you've got those, can you graph them? Nodding yes. So go graph those. Goodness gracious.
I should get a 10-degree.
And then on your calculator, I want you to graph them as well. And we're going to talk about something on the calculator too. It was not offered at my school back in the day. It wasn't offered at my high school. Well, more actually. All right, let's pause. Do your graphs look like this? All right. So we want to find where they do what? Okay, we said we're going to write the solution as a what? A point, ordered pair. So what is that point or that ordered pair? 2, 0. And if I wanted to classify it, what would that be? Independent. No, but you probably will later. So okay. All right. Because it doesn't say. Now this one was nice and easy and pretty and on a little intersection point, right? Not always so pretty. So graphing isn't always your best option. So let's look at our graphing calculators. And let's go to our y equals. And go ahead and put those in. Negative 3 halves at plus 3, right? And 3 halves at minus 3. Okay. Yes, go ahead. Unless you know whether or not. Okay, so now when I go to graph it, and if you need to zoom standard, go ahead and zoom standard. If you want to zoom in a little bit, go ahead. Does anybody need help with that? If you want to check your lines out. Just go to standard. Okay. So now if I go second calc, I can find where they intersect. So we're going to do number 5. So it's going to prompt you. It says first curve, meaning you're on one of the lines. So hit. That's okay. Second calc. And we want to find where they intersect. All your graphing stuff is going to be up here. Okay? So intersect is 5. So first curve means I'm on one of the lines. I'm going to hit enter. Second curve means my little blinking guy is on a different line. I'm going to hit enter. And then it says to guess. So I'm going to move it about right there and hit enter. And it tells us the solution is 2, 0. Okay? Jamie, did you get that? So if you feel good, maybe everybody get it. Okay, raise your hand if you need more time. All right. Okay, let's go on to the next one. Next one we're going to do by substitution. So in substitution, you could pick from this x, this y, this x, or this y. Solve for any one variable. So that's the first thing you're going to do. So you could have lots of different ways to start this. We get to pick to solve for any one variable. Now my little hint is to look for coefficient of 1. So look for a coefficient of 1. Do you see one? Yeah, which one? So that guy right there has a coefficient of 1. He's probably the easiest to solve for. Did you have to do it that way? Absolutely not. Okay. But it will be the easiest. So I would say solve for that y.
What is the variable something?
Just look for a variable with, let's say, with a coefficient of 1. It's not easy. I just Nope. You can if you want, but I'm just going to solve for that y right there. And that y is going to be equal to what? 10x minus 7. Plug that variable into the y of other equation. If you had solved for an x, you plug it into the x in the other equation. Yes. Because all I did was subtract 7 from both sides. So y equals 10x minus 7. Is that all right? I know. If you subtracted it over here, you have to subtract it over here, which is negative, and then get the negative side. Yeah. Okay, so let's see. I'm going to start with 6x minus 3. That y is going to be 10x minus 7 equals 3. Yes? Now we've got it down to one equation, one variable. Can we solve? Yes, do it. Do it. If you need help, let me know. Tell you what you should get. You got that? You're on the right track. Negative times negative. It's a positive. Now what? Final answer needs to be a what? Ordered pair. So if all you have is x equals a number, it's all in ordered pair. So what do you do? Alright, so now that I have 3/4 for x, we have to find the other variable so I can write it as a point, right? So we have to find y. Which one do you want to put it in? We could put it in, let's see, we could put this x in here, we could put this x in here, we could put the x in there. Where would you like to put it? Which one? First one? Sure. I would have chosen the last one, personally, because it's already got y equals. But it is completely up to you. You plug which one you want to put it into and solve. So what did we get out? 3/4. This is my solution. 3/4, 1/2. And my classification. what? Babe.
Well, I knew the solution. I didn't check it out.
Okay.
Stuff is not inconsistent.
Okay.
I want to say because.
Is it a guess or your final answer?
My guess, which is my final answer.
It is correct. Independent is correct.
Why is it?
Because it's just 1 point that you found as a solution. Okay? We're gonna get there. Okay. Elimination. Eliminate. I always think of that show you ever watch, Eliminate. Oh, I don't know. It's not a say, hi, Mr. Rose.
I didn't know before.
Okay. So you're going to line up your X's, your Y's, and your numbers. Okay? Line them all up. Get them in the same place when you want to get the elimination. Oh my God, really? Elimination is a fun way. Really? I don't know elimination. Graphing's my least favorite. Because you don't even get the right answer. Alright, so if I'm lining up, if I start with this first one, if I want to line up the next one, it's very, very close. What would I need to move? The 3y needs to come over, right? So it would be negative 3y plus x equals negative 5. Okay, once I get those, I need coefficients of x's or y's to be opposite. Okay, so coefficients of x's or y's need to be opposite. Well, if I wanted these guys to be opposite, right here, what would I need to multiply the top one by? Think about it. 3, because now that would be a 6. If I wanted then to get a negative 6, which would be opposite, I'd multiply by 2. Does that make sense? But do I even need to do that? Do I need to make my y's opposite? No, because what's already opposite? Okay, the x's are already opposite. Right? So now all we have to do is add. So I'm going to take my 2y minus x equals 3 and add it to my negative 3y plus x equals negative 5. So just add. 2y plus negative 3y. X's do what? Eliminate. Equals negative 2. So what does y equal? 2. Are you done?
No.
Oh, no. Get your solution now. We know the y part. We don't know the x part. I know!
Don't encourage her.
Eliminate.
Wait, what do we do, kids?
Plug it in. Hey, no laughing about that.
Too late.
And what's the classification? Jamie? What is it?
Oh, God. It's going to be okay. I still don't know what the thing is. I'm just thinking about it every time.
When you get one solution, it's independent. All right. Now you're going to see some other things.
We're holding stuff, guys.
All right. Do this one with your group, and then check with me, and then move on. Go. Do that one with your group.
Whoa, word problem.
Any way you want.
This is a word problem.
This is a direction.
You know what? I put my notes in the wrong space of order, okay, guys?
We will get the word problem. Right here. Go. We'll talk. Go. Work. Try it.
I would like to know.
Go. Try it, and then we'll talk.
It reminded me of King Kong. Whatever it is.
I think Mr. Miller can pick out our intermission.
Oh.
We always have a little week dance party.
Oh, nice.
So if you'd like to,
Whoa.
they never dance with me though. Hold on, girl.
Hey, don't get an answer.
Yeah, girl.
Okay, I forgot how to do math. What happens when you do this?
I think that's the deepening. It's really inconsistent for something that's kind of
Okay, good.
So this is like,
so when they cross out
for someone who knows, you know where club at?
Maggie Lane.
Hey, I'll bring you a little paper. Well, you should, because I have no idea where she
Has
is.
address on it, so it's
I forgot.
Okay, so when you do this by any method that you choose, okay, how many of you guys said elimination? How many of you guys said substitution? Okay, so if you chose substitution, actually if you chose elimination, let's start there. So that'd be what, -4x plus 2y equals -6. What do you notice? Kendall, what do you notice about these two equations?
You have to multiply by 2.
And what are they going to be?
And they'll cancel out because they're the opposites of each other.
They're all the same line, right?
Oh, they are the same one.
Because if I multiply this guy by -2, I get the exact same thing.
Oh, do you have to multiply by
That's
2?
what I just negative. Okay.
Oh, I multiplied by 2.
Right? I'm just saying. That would be the exact same thing. Now for elimination, you're probably going to do it by 2. Right? And what happens? 0 equals 0. If you did substitution, you should get somewhere a number equals the same number. So this means that they are the same line.
So they're dependent.
So if they're the same line, think about this. How many times are they going to intersect?
The whole time.
An infinite amount of times, right? So this is going to be what? They depend on each other. So this is dependent. Your solution is going to be all points on the line.
You have to put all that?
Huh? All real numbers for x, and then the y depends on it.
Wait, so I have to write all points.
All points on that line. You can pick for x, negative infinity to infinity. But it's a little bit different because it's a line now. Okay? If you tell me infinite solutions, I am happy with that. Okay? If you you tell me all points on the line, I'm even happier. Both will get you full credit. Try the next one with your buddies. Right. Same thing, right? There's the next one.
So instead of doing one section of it, I have to do two. So I warned them not to go along with
No.
Oh, I know.
You're doing great, man. You didn't even look. Oh, wait, no, you add nothing. What is wrong with you? There's something pretty much. You're never like this. The cocaine. Nothing. Did you get good sleep? Oh, good thing you didn't. You already
Alright, so how many of you guys got, I don't know, you did some work and you got something like this as your final answer?
Yeah.
Okay, so this means, what are your solutions?
No solution.
No solutions. So if you don't have any solutions, what do those lines have to be?
Parallel.
They're going to be parallel because they're never going to touch. And then if we're going to classify, they are inconsistent.
I would probably
Wow.
Are you
All right.
recording today?
Yes. All right. Sydney.
Awesome.
Oh no, fraction.
No!
How do we get rid of them? What do you want to multiply the top ones by? What do you want to multiply the bottom ones by? All right. Get rid of the fractions first. Now, if you want to use 30, you can. 30 is fine.
oh my goodness. I need to go print out papers. I always add them to make sure. Some books for like say subtraction. Well, I just always get off like that. I think it's a lot easier. Like, yeah. I don't like that. Otherwise you'll forget to like distribute the minus from the subtraction.
Oh my goodness. You missed what she was doing earlier. She was thinking about I think some of Ashley's going off now.
All right, so then it gets you to something like this. Does that help?
No.
So you want to do eliminations since they're all lined up?
About that. And then you can but you just multiply.
Okay, like what do you want to multiply the first one by? What do you want to eliminate, the x's or the y's?
Yeah.
The x, so what are you going to multiply by? 3. 3?
Whoa.
So you're going to multiply that one by 3, this one blank, negative 2. Good, they're going to be opposites.
Get it together.
Yeah.
You're literally gonna get punched. Literally. God, can I switch tables? Oh my god. I like you better than that.
Oh, okay.
I don't know either.
That's what you should get for your solution.
Question.
Oh no, I didn't get that.
I will be right there. Alright.
Just kidding, I didn't get that. I don't know how to
Okay, so I kind of like went blank for this number and to be good. You can do it
I don't care.
or you can do any.
I like to do the easiest, personally. A lot of people will say, always the original. So it's up to you.
But it'll work either.
independent.
Independence.
Like, that's something like that.
Okay,
Oh my gosh.
so before we do our word problems, Mr. Miller, just want to give us a little
Please. Pretty, please.
Can we break now before we go to world problems?
That's why we're having just a little break.
So where's our music?
Oh, the J.
No, we need
We listen to that every time it's our.
Well, let's.
Independent. No.
It's not the same when we dance.
Yeah, it's really not the same. What?
No, you should.
It really is.
You should play.
What
You should
kind?
play. Royals by.
You should play that song. That's
I
like
know, but
I like Big Butt.
Let's do what? Let's do what's on my workout for this morning.
I like
Let's see
Big
what the
Butt.
next one was.
You
This
should
is.
I graduated from a
What's
Broadway
the
play.
It's not. When a girl walks in with an A-B, we set her up and into it. Oh, yeah. This is your workout.
Oh, yeah.
I
can't
can't
work
work
out
out
to this
Oh,
song.
My
I
station
understand.
is Pop and Hip Hop Power Workout Radio.
What is it?
Pop and Hip Hop Power Workout Radio.
Hip hop.
You seriously work out to this?
Yeah.
What do you do? Can you show us something?
It's not a skirt.
I hated that day.
Why do you bring it up in
I don't know what you do, so I can't tell you.
Huh? Let's try and get the strike out.
Oh.
Ah. Oh.
Yeah.
We're gonna get you the dance. I like the combination. Oh my god.
Oh my god. I like doing it at the wild skating. Things that can be like stairs and then more time for like a long ride. I don't know if that one is. So yeah.
I was thinking. Okay.
Wait.
Maybe. Yeah, it's like we'll see you next time. Will you email it to me?
Cool.
We have it in my head all day. I need to know. That's okay. Now we have, I think, 2 word problems and then we're done. No, they're not bad.
You think I'm kidding?
Do you know who Tilly Matthews
It goes for us, all books for one price and all magazines for another price. Harriet bought 4 books and 3 magazines for $1.45. And June bought 2 books and 5 magazines for $1.25. What was the price of a book and what was the price?
Awesome. So, unknowns, right? Unknowns, what are we going to have to do? Define the variables. Awesome. What do you want to call? We have a book and a magazine. Okay. So B is what then? The number of books? The what? Okay, so it's the price of a book, right? And M is your price of a magazine. So that's what we don't know. So how many unknowns? 2. How many equations are we going to have? 2. Anybody think they can do the first equation?
4m plus 3.
4. Okay.
So 4b plus 3n equals 4.
Good. Does everybody see where she got that?
Yes.
She said 4 times the price of a book plus 3 times the price of the magazine totaled $1.45. Wow, these are cheap. Where's she at? A garage sale, that's why. Okay. So then write your next one. And then solve with your buddies.
Oh, buddies. Let's go. The second one time. You can help me too.
Well,
I'll do what I want. No, get it. What else, girl? Oh, 3. Myself is together. What?
Anybody doing elimination? Are you doing your graphing, Sydney?
No. What letter?
Substitution?
Marie. No.
Renee?
No.
Elimination?
No, it like this.
What are we going to eliminate?
No, it doesn't.
The B's?
Yeah.
Alright, so what do you want to multiply by here? Well, actually, I don't need to multiply by anything.
M equals 15 cents.
Awesome. Money, give it to me. Money. Yeah, how many decimals for money?
Taylor,
The only time you know you can round no matter what is money. Okay? So I have 4B plus 3. Let me get it to 4B.
So how do you put this in order here?
Well, you just can tell me the price of the magazine, the price of the book. Okay? Good question. Yes. So you're 50?
What?
Okay. I got that song second.
Cool. Me too.
What did you get here? Negative 1.05.
Oh, be early.
M equals 0.05.
No, I wrote 10.
So you're right. No.
Hey, that's a word problem.
Now plug it in. Go find the price of a book.
I got that. Like it's 25 cents.
Yes.
Oh.
Okay.
Yeah.
Let me warn you about your final answer now. Do not write. Okay, this is correct. This is not correct. Okay? Not correct. Why is this not correct? Yeah, so you could write it as 15 cents.
How'd you do that?
I don't know how I just did that. As 15 cents, okay, without the decimal. Okay. So 25 cents, I'm going to plug in M. I don't care where. Just one of the M's. And solve. Okay?
another one.
I actually have a really funny picture I'll find for you after notes about that. I'm not kidding. So your final answer is this guy right here. Because you've already said M is the price of a magazine and B is the price of a book. So if you want to put price of a magazine is, price of a book is, but since you've already defined them, you can leave this as your final answer.
Wait, there's still more?
Okay, one more word problem. And then we're done. And then I'm going to show you the full picture. All right. It is, I promise. When born, Mr. Miller,
Yes.
would you like to read?
Certainly.
Okay.
Winborn, that's a nice name. Winborn has 35 coins consisting of dimes and nickels. If the value of his coins is $3.30, then how many of each type does he have?
All right. So, what are our unknowns? So D, do we want the price of a dime? Is that unknown? No, we know the price of a dime. That's what? Okay, so the number of dimes. And then, what else do we have? N? N is the, okay. All right. Now what? Awesome. So the number of dimes plus the number of nickels equals 35. So this was number, right? And our next one, if I'm going to be using money, I always think money. Okay, show me the money. So number, money. Ooh, how do I put money with D? 10 cents. How do you write 10 cents? 0.1 or 0.10 if you want to. Okay. Plus, how do we write the price of a nickel? Please tell it to me correctly. Think about it. 0.05. Thank you. Not 0.5. That's $50. Okay, 0.05. So now it goes solve. While you guys are solving, I'm going to see if I can find this really quick. So I'm going to take an email. Okay, honest to God, when I was grading Mickey Pup, okay, I went, and this was in downtown Kansas City.
Okay, hold on. So that was half of a
Half a cent.
Yeah, half a
Taco
cent.
is what that was saying. I wanted to go in and say, Taco money! I wanted to so bad. This was their advertisement. How horrible. This is not saying 50 cents.
What if it like?
This was on.
What if it actually meant half a cent?
How?
Wait, what happened? I'm confused.
What restaurant?
You eat that, right?
What restaurant was that?
I get it, because there's a...
All right, so finish.
You guys know, like, do not pay attention. That's what that means.
I can afford that. I can pay for every. Oh my God, I have 8 quarters. I can legit pay for everyone. I got this. Fingers on me. What restaurant is that at?
It was one of the bars downtown. I don't know. It was on Main Street.
Sydney, I know what we're doing this weekend. Dude, let's go. Or sorry, they said Mondays. Next Monday. Is that what it is? Where is it?
If you got that, you can start on your homework.
Oh, got it.
Yeah, I got 31 dimes and 4 nickels.
Yeah, did I write it up?
Oh, yeah, I got 31 dollars.
Okay. I'll believe you. I must have wrote it up.
get it.
Get it. 31 dimes.
Yep. 4 nickels.
Sorry.
It's all peachy.
Let's see if you're paying attention.
May I go look out for these ones?
Can I use the restroom now? No. Can we just go up there?
Oops, whoops, whoops, whoops.
Library.